Welcome everyone. How did everyone enjoy day one? Yeah, good? Yeah, everyone excited to be back in person? Yeah, me too. Awesome. So as you guys probably know, since you're here, we're going to be talking about service discovery and configuration on Kubernetes, particularly in the context of Spring. So thanks everyone for coming. You might have saw me yesterday on the main stage giving my VMware sales pitch. You might think I'm a sales guy, and maybe that's why you, well, I guess you still decide to come, but maybe some people decide not to come, think I'm going to pitch them some VMware stuff. That was just my, I was asked to give that pitch at the last minute. I am not a sales guy. I'm not in marketing. I'm a software engineer on the Spring team. I've been doing that for quite a long time, so don't worry, I'm not going to sell you anything in this talk. I've been doing that for a couple years now, about 6 years. I really enjoy being on the Spring team and working with all the great people that you saw on stage yesterday and have been seeing in the conference, throughout the conference from VMware. My teammates are incredibly smart, and I'm humbled to be working alongside them. I've been working on the Spring Cloud team the entire time I've been with VMware/Pivotal, and I've been working on a variety of projects from the Spring Cloud config server to Spring Cloud Netflix to the gateway, all kind of dabble in everything. Lately I've been spending a lot of time on Kubernetes, which is why, hence the talk today. That's just a little bit about my background. If you want to get in touch with me after the conference, feel free to reach out to me on Twitter. I'm at Ryan J. Baxter on Twitter. Always happy to engage, chat, direct message me, whatever. Happy to talk to you there. All right. So, who here is using Spring Cloud today? Okay, a lot of you. Awesome, great. Anyone here using Kubernetes? Just as many. That's pretty cool too. All right, so as you guys know then, since you're all avid Spring Cloud users and Kubernetes users, you realize that there's a lot of different options right out there as far as service discovery and configuration. And from the Spring Cloud side of things, we've had a lot of these things in place long before Kubernetes was around. Right? We've had things like the config server, a discovery client. Someone Siri talking to us here? We've had things like the config server, a discovery client, discovery server with things like Eureka and Consul and Zookeeper, and built on top of those things, load balancing with Netflix's Ribbon and Spring Cloud Load Balancer now for quite a long time. And we've had solutions to these cloud native problems before people realized there were a problem, and at least for most people did. As this cloud native landscape has evolved and platforms have evolved, et cetera, and Kubernetes has come along and realized that, well, hey, everyone who deploys an app on a cloud platform has these issues, so why don't we make it part of the platform, right? So in Kubernetes, you'll see platform-based solutions to doing service discovery and externalizing configuration. So when we talk about taking Spring apps or Spring Cloud apps and running them on top of Kubernetes, oftentimes people come to me or ask me or my teammates and be like, well, what do I do here? Do I use what's in the platform, or do I use what Spring Cloud has, and what's the right solution? Right? So we're going to talk a little bit about that today, and some of the different options that you have. So just so we can all be on the same page here, we have just a quick rundown of what the equivalents are between Spring Cloud and Kubernetes. Right? So as you're all familiar with, we have the config server from Spring Cloud and the config client, and that serves up externalized configuration via your Git repos, Subversion, Vault, whatever, pick your backend, and then the equivalent on Kubernetes is something like config maps or secrets, which, for those of you not Kubernetes wizards out there. Config maps and secrets could just be key value pairs. They could be, it could have a YAML file or a properties file stored inside it. There's lots of different options. Then really the difference between a config map and a secret is not really that big of a difference. Just secrets are meant to be secret, right? So they usually contain things like usernames or passwords or things, you know, confidential information. But you could put anything that you put in a config map into a secret if you wanted to. Discovery server and discovery client are really kind of based off of the creating what's called a Kubernetes service, right? So the fact that you create a service on Kubernetes for an application that you're running there then exposes it to some degree to external applications, right? You could expose it to just other applications running inside the cluster or inside the namespace that you're within on Kubernetes, or you can expose it externally depending on how you configure the service. When you configure the service in Kubernetes, the act of doing so will then allow causes two things to occur. You can make a request to that service over DNS and Kubernetes will resolve the DNS name, which is basically equivalent to the service name that you created for that service. And it will also inject environment variables containing the IP, protocol, and port into other containers that are running on Kubernetes, right? So, for example, down here we have like this Redis example. I have a Redis service, and if you look inside other containers that are running, you know, you'll see these environment variables that are exposed for that Redis service. So you could then make a request to that service by either using the DNS name or by looking up these environment variables, finding the IP address and the port and the protocol, and doing it that way. For load balancing, that's also done at the service instance on Kubernetes. So you'll make a request to like I said, the service, either DNS or with the environment variables, and that request goes to the service, and the service will then load balance it across what's called all the pods, which you can think of that as a pod is an individual instance of the application that's running. So it'll load balance their requests across all the pods that happen to be running for that instance. And as we'll discuss later, one of the downsides here for load balancing on Kubernetes, as opposed to using something like Spring Cloud Load Balancer, which is client-side load balancing, is that in Kubernetes, you really have no control over the algorithm that's being used to load balance your requests. It's all at the platform level. It's configured by the operator when they set up Kubernetes. So it's kind of out of your hands as an application developer, whereas if you're using something like Spring Cloud Load Balancer, you have complete control over all that stuff. So pluses and minuses to everything. Oops. All right. So just a visual representation of what we just talked about on Kubernetes here. So this is just a basic example. We'll start over on my right, your left, I guess, in the configuration side of things. So you'll see we have a config map and secret. And typically how you get the data from the config map or secret into the applications that are running is by attaching them to a volume and then mounting that volume inside the application, the pod. So those, depending on what's inside the config map or secret, will depend on how that shows up inside the pod. But basically, it's going to show up as some type of file running inside the pod that you can then load that configuration into the application that's running. So from as we'll see, from a Spring point of view, you're going to use something like Spring config import and point it at that file to load the configuration, whether it's a key value pair or YAML file or a properties file or whatever. From the service discovery, load balancing, and discovery server point of view, like I said, if you want to make these pods accessible to other applications, you have to create a service for it within Kubernetes. And like I said, the act of doing so will then allow DNS name resolution to occur, or you can, the environment variables will be created inside other pods, right? So here we have a client that's going to make a HTTP request. It could be another Spring app. It could be whatever. It's going to make an HTTP request. It's going to go to the service. The service will then load balance it, like I said, across the various pods that are running. Does that, anyone have any questions about that before I continue? Everything clear? If anyone has any questions, just feel free to raise your hands and, or shout at me or whatever. Okay. So without Spring Cloud in the picture, we have, just running a Spring Boot app on Kubernetes with what we now know. We have a couple of different things provided by just Spring Boot in general that allows to build cloud native applications and really makes things kind of easier on Kubernetes. So first, from a configuration point of view, I mentioned a second ago, we have Spring Config import. This is introduced in Boot 2.4.x, I believe. It could be earlier, but I think it was 2.4.x. So it's been around for a fair amount of time at this point. And you can have a couple of different options for loading config maps and secrets using this. So you could point it directly at a file. So you could use this file prefix, file : / whatever, wherever you mounted that file from the volume, mounted the volume to inside your pod, and load the configuration that way. The most common way, as we'll see in the demo, is to use something called config tree. And this is just pointing it at a directory. So basically, if you have a config map and or secret that's just a bunch of key value pairs, you mount that as a volume inside of your pod. Those key value pairs, the keys get created as individual files, and the contents of those files are actually the values. So you'll see a bunch of files created for each key value pair inside your config map or secret, right? So basically what you do is say, I have Spring Config import config tree. This is where all those properties live. These are all these files that I mounted live. And it will load, Boot will load all those files as configuration properties into the application context. The one thing that's missing here that a lot of people like from a Spring Cloud perspective, some of you might use, is what happens when you change that configuration, right? So I go to my config map, I change my foo property to be from false to true. That does something inside my application. What happens at that point, right? So what are my options? Well, Kubernetes will actually reflect that change in the mounted file, inside the pod. So if you go and look at that file, it will now say true. But Boot has no idea that the configuration property changed. So how do you solve this? In the Spring Cloud world, you would normally get, we have this refresh endpoint that you can hit, and the application will refresh its configuration without having to restart. A lot of people love that. In the Kubernetes space, they generally don't have anything out of the box that supports that. So your options are to basically restart the application or implement some kind of refresh thing on your own. Restarting the application is not entirely a bad thing on Kubernetes, because you can have X number of instances of that application running. You can do what's called a rolling restart, and it will restart each one of those applications individually. So there's always at least one up at any given time, making sure that it can serve incoming requests if need be. So it's not like it's a catastrophe. There is a solution to the problem, but if you're a Spring Cloud user, you might be expecting that functionality or rely on that functionality or whatever, or like it, and it's not there out of the box with just Kubernetes and Spring Boot. From service discovery, like I already mentioned a little bit here, we create a service that makes it exposed to the other applications that are running. We can now make requests to that service. You'll just use REST template or web client, however you normally would. There's no magic involved. There's nothing really looks any different. You don't have to worry about load balancing or anything like that, because it's all done at the platform level. So that's all cool. Like I mentioned with load balancing, the algorithm that's going to be used though is completely out of your control. You have no idea what's going to happen. It could change. It's kind of just you got to rely on it working, I guess. And related to service discovery and load balancing, we have liveliness and readiness probes set up by Kubernetes. So Kubernetes will hit an endpoint or check. There's various different ways you can configure this, but in general, Kubernetes hits some type of HTTP endpoint on the application, and if you have Spring Boot actuator on the class path, it will automatically expose actuator /health/liveliness or /readiness for your boot application. And if you configure Kubernetes, when you deploy the application, it will hit those endpoints to see if the application is alive and ready, right? So if it's not ready, for example, or not alive, Kubernetes will take it out of the load balancing, the instances that are available to load balance across, right? So those are key when we're talking about, making sure that we're making requests to things that are actually going to respond with actual data. The other thing I want to mention, just on the configuration side of things, there are some nice configuration features that are part of Spring Boot for Kubernetes that you can find useful. We'll see some of them today in the demo. We have conditional on cloud platform. So if you have some type of control component or whatever, or configuration or whatever that you only want to enable when you're running on Kubernetes, you can say @conditional on cloud platform Kubernetes, and that will only be enabled when you're running on that platform. Inside your properties file or YAML file, if you have some type of configuration that you want to only activate when you're running on Kubernetes, you can say spring config activate on cloud platform, again specifying Kubernetes. And if you have some type of logic that you only want to run on top of Kubernetes, you can say cloud platform.kubernetes.is detected, pass it the Spring environment, and it will figure it out. And then you can execute whatever logic you want to have. So there's some nice stuff out of the box just with Spring Boot that you get. So as I mentioned, we have a lot of abstractions for a lot of these things inside of Spring Cloud, and they've been there for a long time. And you might be asking yourself, well, I want to run my Spring Cloud application. Yep. Please bring it, Mike.
Thank you. I have a question about the scenario that you mentioned when a config is changed and the change is propagated to the mounted volumes. And you mentioned about hitting the refresh point. Is there, because like you said that restarting the pods or calling refresh point is not bad, but is there an out-of-the-box solution to monitor the changes on the local files from Spring?
Not with just vanilla Spring Boot. We'll address that point in a second here in this next slide here.
Oh, okay.
So, yeah. So in Spring Cloud, we have a solution for that.
Yes, because restarting the pods is like, it can change the metrics. There are some metrics like number of restarts per pod that can be mislead the metric. Yeah.
Sure.
Okay, good. Thank you.
Yep. So like I said, we had a lot of these abstractions around building cloud native applications, configuration, service discovery, load balancing in place in Spring Cloud for a long time. And now if you have been using those things, those interfaces, abstractions, etc., and you want to move and run these applications on Kubernetes, you want these things to work generally without having to change your code, right? You don't want to have to take them out. Maybe you can't take them out. There's a lot of different reasons why you might just want to take the application you have today and just put it in Kubernetes, right? But you need to have, implementations, interfaces, functions, features, functionality there on the platform in order to make it work, right? Because the solution is not to deploy Eureka on Kubernetes, right? That's not really what you want. You already have service discovery there. Why are you deploying a service discovery server, right? We have, this is where Spring Cloud Kubernetes comes in. It's basically providing implementations for a lot of these Spring Cloud components on top of Kubernetes, right? So it allows you to, just move the application over, and it should work out of the box with adding a couple dependencies to your POM and maybe doing a little bit of additional configuration, but otherwise leaving your code unchanged. So you'll see here, if we look on the left side here, we have, I'll start at the bottom, we have, I'll start with the Spring Cloud config server. So you can deploy the Spring Cloud config server to Kubernetes, that works fine, right? Maybe you have your configuration already here in Git, Subversion, wherever, right? And you're pulling that configuration, you want to leave that there. You don't necessarily want to take everything that you have in Git and convert it all to a config map. Maybe you don't want to do that, or it's just not possible to do it because you have other applications that are going to be using this, right? So, but maybe you have some configuration that's going to be very specific to Kubernetes that you don't mind putting in a config map. And you also want to just surface it all from the config server. So we have a version of the Spring Cloud config server that you can deploy that will pull, that just basically adds another environment repository for config maps and secrets, right? So just like you have an environment repository for a Git repo or a Subversion or Vault or whatever, we now have one that supports config maps and secrets. So if you have configuration that's very specific to Kubernetes that you want to pull in addition to what you have in Git or wherever, we can do that with the config server running on top of Kubernetes, and you're going to point your application to the config server just like you do today. From a service discovery point of view, we have a new component here at the bottom called the Spring Cloud Kubernetes Discovery Server. And this really behaves a lot like Eureka in that the REST API that it exposes looks a lot like Eureka. The data that comes back looks a lot like Eureka. It's a very nice model. You know, we built it off of that. But the information that's coming back is coming directly from Kubernetes. You'll see it talks to the Kubernetes API server to fetch all the services and endpoints for your applications. And that's how it gets the data to return back to the discovery clients of what services are available. This in turn allows you to do things like client-side load balancing using Spring Cloud Load Balancer, which relies on the discovery client interface in Spring Cloud. So now you can do client-side load balancing, right? So now you have complete control over if you have a load balanced REST template or web client in your application today, you're using that annotation, it will continue to work on Kubernetes. And again, you'll have control over what algorithm gets used, caching, all the functionality that comes with Spring Cloud Load Balancer is now enabled on top of Kubernetes. Now, to address the gentleman's question about refreshing configuration, we have another application that you can deploy called the Config Watcher. And I don't actually have that running in the demo that I'll show today, but basically how this works is it again uses the Kubernetes API server to watch all the config maps and secrets. And when it notices that something has changed in one of them, it will notify the application then that the configuration has changed and either send, in this example, in this diagram, I have it using RabbitMQ. You don't have to use RabbitMQ. You don't have to use a messaging server. You could do this over HTTP. So you could take that completely out of the picture. I know a lot of people don't want to use that, and that's fine. So you could do, the config watcher works with Kafka, RabbitMQ, or just plain old HTTP, right? So it will make a request, an HTTP request to the pod, calling the refresh endpoint on it and refresh its configuration, pulling in the new configuration from the config server then for those config map changes, or if it's a change in Git or whatever, right? Yeah, I think that covers everything. Any questions about that? Yep. It's just service discovery. Yeah, it's just like a Eureka server, if you're familiar with that. Yeah. All right. So let's jump into the demo. And so some of this will make a little bit more sense for you, hopefully. You can see it live in action. So if at any time I put up text on here and you can't see it, just let me know and I'll try and make it bigger. Sometimes I forget. So the application that I have running here is, or we're going to use today is it's a fictional application. Obviously, it's a temperature sensor application. So it's going to, we're going to have a bunch of temperature sensors running. The temperature sensors are going to publish data over RabbitMQ about what the temperature is and where it's located, and we're going to just have a front end that actually displays that data. So I'll just show you quickly what some of the palms look like so you have an idea of what kind of dependencies we have on the class path here. So you can see we're just using Spring Boot 2.6.7. Sorry, I didn't have time to upgrade 2.7 before the conference. And we have Spring Cloud Stream Rabbit on the class path. We're using Spring Cloud Starter Config. We're using Spring Cloud Starter Load Balancer. We're using Spring Cloud Starter Netflix, right? So this is just like a vanilla Spring Cloud application. There's nothing fancy going on. all the palms pretty much look exactly like this, so I'm not going to show there's 3 applications. I'm not going to show you all the palms for all 3 applications. But they all pretty much have these same dependencies. They're all talking to config server. They're currently using Eureka to do service discovery. They're using Spring Cloud Load Balancer, etc. Right? So we have 3 applications, like I mentioned. There's this locations application. This is I'll show you quickly. The code is very easy to understand. This is a very basic application. It is a web application. It has one endpoint on it at the root called getLocation, and it literally just returns a random location in Spain. Right? I Googled what are the 17 most popular locations in Spain, and that's what came back. I don't know whose opinion that is, but that's what that does. We have this Spring sensor application. This application is the thing that's acting like the temperature sensor. So what it does 2 things, 2 important things. We have this Spring data source here. So every 5 seconds, it's going to go ahead and check if it has a location. If it doesn't have a location, it calls that location service I was just referencing a second ago to get its location. This is all fictional, right? So it's not the best thing in the world. And then publishes some random temperature data, basically, every 5 seconds, right, over RabbitMQ. And then, just so we look quickly here, we're using a load balance REST template in this location service that the temperature sensor data is using. It's making a request to Spring Sensor's location service, right? That's the service name for the location service, right? So this is nothing new as far as Spring Cloud is concerned. The final application here is the sensor. This is, again, a very basic application. There's nothing particularly interesting that's happening. It has a data sync, so it's receiving the data that's being published by the temperature sensor, saving it into an in-memory database in this case, just a JDBC database, so nothing fascinating, but it happens to be in memory. And it also has a front-end controller for some HTML that's then going to display the temperature data that we have here, just a basic HTML page, right? So nothing fascinating. So in this basic Spring Cloud application, I have a Eureka server and config server. The config server is pointing at this repo here with this configuration for the applications. This folder here is actually up on GitHub. So I'm going to come back to this Kubernetes thing in a second. We just have some stuff we have an application.yaml. So for all applications, this configuration will come down. Then we have some specific configuration for the Spring sensor, the front-end application, as well as the sensor application. So there's nothing mind-blowing here. This is all basic Spring Cloud stuff. Inside, like I said, inside the application, the YAML for the applications, again, they all look pretty much the same, so I'm just going to show you one here. I'm going to come back to this part in a second, so hold off on any questions about that. We just have some configuration to point at the config server and whatever port it's going to run on locally. So just to give you guys an idea, I will run everything here locally. I already have my Eureka server running and config server running, just in saving us some time. And I'll start up the other 3 applications. I also already have a RabbitMQ server running over here, so locally. So just so you're aware of that. So make sure everything starts up quickly here. So as it connects to Rabbit, hopefully. Should see that happen fairly quickly. There we go. Okay, and then we'll start up the front end application. So we're going to go to the browser, local host 8080. The app is not up running yet. There we go. Okay. Oh, there it is. So this is what it looks like, right? Just this is the UI. We have one sensor running. It's publishing data every 5 seconds. Nothing fantastic. Okay. All right. So now we want to get this application running the way it is on Kubernetes. Right. So how do we go about doing that? Right. So I'm going to save kind of the not so fun details. I've already built a Docker image for this thing. I already have it published out into a container registry. You know, we've talked about that a lot. You know, I'm saving some time and skipping over that part a little bit. But as far as, you know, once we have that there, how do I get this thing running? So there's one thing, there's some stuff that we've added to the palms here, right? So you'll see that I have Spring Cloud Starter Kubernetes Discovery Client here, right? So that when we're on Kubernetes, we have the Service Discovery Client from Spring Cloud Kubernetes enabled, right? But we don't want Eureka and the Discovery Client running at the same time, right? Because we're on Kubernetes, we don't want to be trying to make requests to Eureka, right? So you'll notice before I kind of skipped over some stuff here. We have the other thing I need to configure is, we'll take a look at this in a second, is to make sure that when we're on Kubernetes, we're making requests to the right config server, right? So that's why I have Spring Config Activate on Cloud Platform. So this is only enabled when we're on Kubernetes, and it overwrites the Spring Config import statement to say point to the config server, which is located here running on Kubernetes. Okay. And when we're on Kubernetes, the other thing you'll notice is that I had this here in the Git client, in the Git configuration with Spring Cloud Kubernetes Discovery enabled false. We're on Kubernetes, I want that to be true, right? So how do I do that? Well, so in my config map that I'm going to deploy to Kubernetes, I have Spring Cloud Kubernetes Discovery enabled set to true, right? So it overrides that so that we're on Kubernetes. I want that to be true. It also sets the discovery server URL. You also need to know where RabbitMQ is located on Kubernetes, right? So this is why I created a config map here, because these are all things that are very specific to Kubernetes, right? We're disabling Eureka, right? So this is my Kubernetes specific configuration that I'm going to deploy to Kubernetes. I also have a secret here, which has the username and password for RabbitMQ on Kubernetes. And then the other thing that I have is deployment YAMLs here for the config server and discovery server. So the config server, we have an image for that. We publish it as part of the Spring Cloud release. It lives out on Docker Hub. You can go to our documentation for Spring Cloud Kubernetes. All this is right there for you. So that's where that image is located. It's already there. There is an environment variable here that we're saying enable on Kubernetes, just like you enable other environment repositories in the config server. You specify a profile, Git, Subversion, Vault, whatever. When you use the Kubernetes config server, you'll specify Kubernetes to enable it to pull information from config maps and secrets. The rest of this is pretty much basic Kubernetes YAML, which I'm not going to bore you with because it's boring and it's YAML. It's just very verbose. Same thing with the discovery server. Again, it's an image that we publish out to Docker Hub as part of the Spring Cloud release. So it's out there, it lives out on Docker Hub. You can go ahead and check it out. It's, again, all in our documentation. If you're wondering how you're going to figure this out later, it's all there in the documentation for Spring Cloud. And yeah, the deployment YAMLs for these individual applications, they're pretty boring as well. There's nothing, you know, this is just Kubernetes YAML. This is just where I've pushed the image beforehand, just in the interest of time. This is my repo out on AWS. so that's just all that is, right? There's nothing mind-blowing here happening from a deployment perspective inside of any of these apps. The only other thing that might be of interest, I guess, is looking at the service YAML for one of these. It's not, the only thing why it's of interest is because of the name here, but because that's the name that's going to be exposed as the service inside of Kubernetes that you're going to make a request to. So, but other than that, everything looks pretty much the same. So what I'm going to do here is I'm going to apply some of these YAMLs. So we're going to, oops, kubectl apply dash f application. So we're going to apply the config map. And the cluster that I'm using is just a cluster I have running out on AWS. It's nothing special about it. It's not fancy. It's just a plain old vanilla Kubernetes cluster. So we got the Kubernetes, the application YAML, the secret as well created. We're gonna deploy the config server, and we're going to deploy the discovery server, and then we're going to deploy the applications. So I'm going to make sure that those are all look like they're coming up and running. So we see our config server coming up. That's up and running. The discovery server should be starting as well. There we go. All right. So let's deploy the other apps. So if we do kubectl apply -f spring sensors location service Kates. All right. That's our location service. We need sensors Kates. And then we're also going to do spring sensor kits. All right. So let's see if those look like they're up and running or they're starting. The one thing I forgot to mention. So to make it a little bit more interesting, in my deployment YAML for the sensor, the application that looks like a sensor, it has 5 instances that get running, right? So we have 5 different sensors running. That's why you see a bunch of the pods here that are spinning up, hopefully. All right, looks like things are coming up here. So while that's happening, I'm just going to go look at the services here. So let's check out, just to show you what the configuration server looks like. So if we make a request here, /application/default. So this is the response back from the configuration server. So you can see we're pulling configuration out of the Git repo, like we were before. And then we also have the config map and secret also coming back as property sources as well. Right, so this is what was in our config map. This is what's in our secret. And that comes back in the response from the config server, right? Now, if I wanted to do the specific application, right, I could do sensor spring sensors sensor. Right. Here we get the application YAML as well from the Git repo, as well as the Spring sensors application YAML from the Git repo, plus our config maps and secrets. Right. So it's just exactly how the config server has always worked. Right. There's nothing special here with the addition of just pulling information from config maps and secrets. And the discovery server. Let's check that one out so you can see what that looks like. Again, it's not gonna look that different from what you're used to seeing in from something like Eureka. But here we're just getting all the services that are exposed via Kubernetes. So we see the discovery server itself, the Spring Sensors application, the config or location service. There's a Rabbit service that's also exposed. That's coming back. Oh, I forgot to already mention, I have a Rabbit server already running in my cluster. So again, just saving time. I didn't want to have to deploy that. And then the config server itself. But yeah, there's nothing. You can see it gets the host name, the ports, all that stuff are all, just normal stuff that you'd expect to see here. Yeah. So that's what that looks like. So let's see the app itself. So if we hit this URL, I really wish AWS came up with a way of like making these URLs not so crazy, but I'm sure there is a way, I just don't know about it. So here's our app. So again, 0 code changes, just adding some dependencies, a little additional configuration, works as expected on Kubernetes. Okay, great. So we got there. Now, what if you're like, I'm going to go to Kubernetes, or I want to move my application to Kubernetes, and I have no need, like I don't want to use Spring Cloud. I don't have any need for it anymore. I'm not going to be running on any other platforms. I'm fine with ripping it all out. Or I'm building a completely new application, and I'm just going to run on Kubernetes. Do I need to use Spring Cloud? No, you don't have to. I won't. I'm a little heartbroken about it. Like, I mean, I'm on that team. Part of me wants to say you must use it, but honestly, if you don't want to use it and you don't have a need for it, you don't have to. You can just rely on what the platform gives you, which is one of the greatest things about Kubernetes, right? So we can take these same applications and just leverage the platform. You'd have to, I have to make some code changes to do it, but it's possible, right? The same functionality is just possible using Kubernetes as a platform. So what I'm going to do is I'm going to check out a branch where I've already done this. And I'll show you some of the changes that come along with doing that. So obviously we're not going to, I don't really care, you can see IntelliJ is going to say, you don't have, these projects don't exist anymore, right? We don't have a config server, we're not using a discovery server anymore, right? So if we look at, for example, the POM now of these applications, the only thing that's here is Spring Cloud Stream for publishing data over Rabbit. There is no config server dependency, there is no discovery client, no Eureka, no Spring Cloud, Kubernetes, none of that, right? That means that in our application YAML, there is no config server here anymore. There's just, when we're on Kubernetes, I'm going to point to this place here, right? And we'll explain where this is, right? So I'm going to import some configuration from config maps that are going to be located at this directory here. Here is that config tree thing I talked about earlier. This optional prefix means don't freak out if it's not there, right? But that's all that really means. You can see there's no Spring Cloud dependencies here anymore. Same is true for all the other applications. There's no dependencies. All that configuration that we had has been removed. If we look at our config maps and secrets here, some of the configuration that was once in Git has now been moved to these config maps, right? We're not using Git anymore, so we had to take that configuration. We put it all in a config map, right? So we have a general config map for all the applications here. Again, with our RabbitMQ username and passwords and just some general Spring Boot stuff. Oops, that's not going to be good. And there are some now, if we look at what we gets deployed to Kubernetes, we do have some config map data for individual applications, right? So we have the Spring Sensors config, which is setting up Spring Cloud Stream, all that fun stuff, right? And I realize we're running out of time, so I want to make sure that this works. So I'm going to stop talking and. Oh, I gotta Kubernetes. Here. CTL apply dash F application figmap. Secret and spring. All right. Let's see if we can get this one more to run here and see if things kind of come up. Pods. There we go. All right, look at the services. Just see if this works here quickly. Ugh. Come on, we got 2 minutes. No. AWS, why must you hate me? Shoot. Sorry. Now I'm rushing through and not explaining what I'm doing. Ugh. It makes me so sad. Why? Why? Oh, we're doing, yeah, there we go. All right, okay. See, all right, it worked. All right, we have 1 minute. I'm going to show you something real quick. So the configuration, the one thing that I really wanted to show, configuration, pick one of these here. CD etc config. So we're looking inside the pod here, and so hard to read. These are the config maps and secret data that gets mounted as a file inside the pod, SSH or a shell inside one of the pods. This is what the configuration, the config maps and secrets get mounted inside that pod, and that's what the config tree thing is pointing at, right? So each one of these individual files is a property. If we do like more spring rabbit host, for example, you'll see the value is, when I don't put a tick mark there, is sensors rabbit, right? That's the value of the property. All right, I'm sorry I ran out of time. If you guys want to ask me questions, I'll be outside. I know that the next presenter has to come in, so yeah, appreciate everyone coming.